is to include student presentations in the other presentations of the somehow more older physicians and researchers. And so this is a test, yeah. And so let's have a look into the next presentation that comes from a student group that bases their work on I think 3 semesters of work with students from electrical engineering and mathematics and so on, to now come up with a methodology how to be able to assess the quality of CTG devices. Because again, the problem is here, you have to trust the manufacturers, but the manufacturers themselves, they always have this conflict. And but usually there is no funding for having an independent methodology to check what's the quality of different CTG devices. There's a very famous work from Professor Morgenstern, like 20 or 25 years ago, who has done an independent check of the quality of CTG devices at that time, and the results were shocking. So he found that when he had a little glass cylinder with a gold standard, what he called a gold standard, where he knew what should be the outcome of these devices, it was very different. In particular, there was a suppression of variability for in decelerations, and his argument at that time was there's an additional increased risk of unnecessary interventions. And so we've been struggling now over the last semesters to build something. It was partly like a game, yeah, to let students really work and flourish and have fun. And at the end, we found a solution now that came from a completely different topic about foot sole sensitivity, where we found a machine that turned out to be rather useful. So I'd like to hand over now to what we call the Ctg Simulation group to display their video. And then I think we have a very powerful audience to have a good discussion about this.
Okay, good morning, Matti. Good morning, everyone. I'm going to set the window.
Monitoring a fetus's heart rate during pregnancy is one of the main indicators of well-being of the fetus. Commonly, expectant mothers make appointments regularly and visit clinicians for monitoring sessions. With the current enhancements in the technology and also the effects of the COVID-19 pandemic, at-home monitoring devices became attractive, including cardiotography devices for fetal heart rate monitoring. There are various numbers of commercially available home monitoring CTG devices on the market, which brings us to the question, can we trust these devices? Are they accurate as they are claimed to be? There are some publications regarding the accuracy of CTG devices, both in clinical and home settings. However, most of the studies do not make a comparative analysis. They are mostly clinical trials without a setup that could be used to test different devices comparatively. Previous student generations started a project to design a reliable test setup for evaluating the accuracy of home CTG devices. Previous approaches were based on using motors and inflatable balloons to simulate the fetal heart rate. In the new test setup, a shaker is used to simulate fetal heart rate measurements taken in a clinical setting using gold standard CTG devices. The shaker can oscillate with a predetermined frequency pattern. For this purpose, a setup including a microcontroller, a filter circuit, and an amplifier is used to convert and deliver real-life fetal heart rate data to the shaker. To simulate the mother's ureter, a plastic bag filled with water is placed inside a vessel with 2 holes on the sides. On one side, the shaker is placed, and on the other side, the desired CTG device is attached. The measurement data is sent to a server during measurement, later to be evaluated. To ensure the test setup was free of bias or any systematic errors caused by the shaker, we first evaluated the performance of the shaker by comparing input data taken from a real CTG measurement with the output data we measured with 3D accelerometers placed on the shaker. After concluding that the shaker is reproducing the heartbeat pattern with a high accuracy, test setup was used to evaluate the performance of two different commercially available at-home CTG devices. For a valid evaluation, measurements carried out with both devices were compared to a measurement which was taken with a benchmark CTG device for fetal heart rate monitoring in clinical settings. For error analysis, different methods are used. Here, it is shown a Bland-Altman diagram, which is typically used in medical statistics. The average measured heart rate of the home CTG device and the benchmark CTG device is plotted against the error between the measured heartbeats. It is seen that not all the data points lie inside the confidence interval of 95%. With this, we concluded that tested home CTG devices are prone to error, which should not be neglected. In this project, it is shown with this test setup, different CTG devices can be tested and evaluated without needing a real fetus, so that the safety of these devices could be tested in a more standardized way. We would like to thank Professor Martin Daumer and our colleagues at TRIM who supported us in the course of this project. And finally, we also would like to thank you for your attention, and we are looking forward to answering your questions.
Okay, so thank you very much for this work and the presentation. So before opening up the discussion, so there was the plan to have actually two student groups merging, but one of them had to actually go back to his home country to have a medical intervention, so he could not really be present here. His name is Etay, and I think we should mention also his part.
Yeah, I wanted to, if I may interrupt just briefly, because I also would like to thank you as well, Martin, for supporting us, and all the other colleagues at TRIM, and especially like Christian, hello. And also Etay, because he was also in the previous student project, and he really supported us during the project. So we would like to thank him especially for his help and support. Yeah.
Thank you very much.
Oh, here he is.
Ah, here he is.
Yeah, I sent him the link.
Okay, so excellent. So that's well, I'm somehow maybe biased. I don't say anything. So let's see if anyone has any questions or comments or.
Yes, maybe me. Can I give a brief overview about which devices you have compared and what was the challenges?
We're not sure if we should openly name the devices that we tested, because I believe for making a solid conclusion, we need more data and more test setups, and also maybe the opinions of the clinicians as well, because we have not enough knowledge in this field. We're fairly new. But the main challenge is one of the devices only started the measurements when it detected the mother's heartbeat as well, and for that it used not a Doppler sensor, but an optical one.
Mhm.
And our test setup was not really designed for simulating an optical sensor and kind of repatterning a mother's heart rate. So we had definitely difficulties with this device. And other than that, I think our test setup also lacks the simulation from the mother, which is kind of an interference in this Doppler frequency measurements. So maybe adding this to the setup could also be an enhancement and useful to see if these devices really could really differentiate between the interferences coming from the mother and the real heart rate, baby's heart rate.
Mm-hmm. Thanks.
Yeah, thanks a lot. So just to avoid the impression that I ask my students to sign confidentiality agreements, so this is not the case, but it's okay. I see why you don't want to mention it. You don't have to say, well, the one from company A was better than from company B. On the other hand, I think it is completely okay for the audience to know which devices we have used. Yeah?
Okay.
So for
okay. Yeah, for the gold standard device, we use Philips. I think it was series 3050, as far as I remember. And for the other two home CTG devices, we used one from the company Harabeats, and the other one was from the company Lancome.
Yes, and Harabeat was also the one that was used by the case study at their review. Yeah. Okay, Antonia, you have hands up.
Sorry, I really enjoyed this. If you don't mind, I even took a screenshot and sent to someone in my team because he will find it funny as well. I couldn't stop laughing. No, great job. I mean, this was yeah, a lot of work. Two questions. One is why do you need to do that? Is there really no other way? I honestly don't know. I mean, I know there's some commercial simulators. I know when we need to simulate in my work, you know, we have a real monitor, but then we tap. But then, so we don't have an actual pregnant woman to put it on. So we tap. My colleague, he's tapped a lot different songs. So he plays music and taps to different. Anyways, when he wants to, and we have other simulators, I think sometimes. So anyway, so is there no other way? Is this I mean, we need a simulator, so it is perfect. What you seem to have done is wow. Is there no other way? And my main question is, what are the next steps? Because it's very interesting. You got my interest. So what is next?
As far as I know, maybe Etay should answer this. Previously, I think the motors or the other setup they used, they were not really optimal for the frequencies, because I think the fetal heart rate is a little bit faster than a
yes, I can explain this for I can explain this. This is actually the third trial that we're trying to do the simulator, because it just didn't work in the other setups that we had. They tried to do this with a stepper motor before our second trial, where we tried to operate a pump with the motor. The problems that we had with it is that we couldn't really reach the speeds that we wanted, and the stability was very the stability was not very constant. So this device that we used for the simulation, called a shaker, is actually used partially also in order to test the cargo that is being sent to space on spaceships, to test the resilience of this cargo. It's actually a very powerful device. It's much more powerful than what we used it for. It can do it could deliver some serious power to as a signal. We obviously used it in frequencies and in amplitudes that are similar to that of a human fetus. This is actually not a very trivial task because, as you said, that your colleague had to tap it manually. What's really good about this is that you can insert entire CTG recordings from actual fetuses and feed it into the device, and it can perform the simulation for hours. And you can test different patterns, different changes in patterns. You can
I love it. I love it. No, it's great. I love it. Just I haven't thought this way.
Yeah, and maybe if I may also give another comment. So as you said, well, there is this difference between tapping. We are all in Trium. They're all good tappers. So we have all very good fetal heart rate simulators with their hands. And then you've got the other end of the spectrum, which is the actual pregnant woman. And there is a lot of space in between, as you may agree. And there is a lot of evidence, at least in the earlier generations of the big machines even, that there's a huge difference sometimes between what you get on the display and what is really happening. And without a good methodology and independent systematic research, no one will find out. Yeah? And there is has been a tendency over the years of development that there has been built-in smoothening, yeah, in the machines, such that the variability that you see on the device, yeah, is actually generated by the algorithms. It's not the true variability. And as we all know, in particular STV and whatnot, I mean, a lot depends or may depend on the algorithms that you use for, or the data that you use for training machine learning algorithms. Well, they depend on the accuracy of the raw data. And if the machines somehow do something to the raw data and you have no control about this, then this is not good. Yeah. And so in the next steps, so we will buy probably another shaker for being able to simulate twins, because I'd like to see you when you simulate twins by tapping. Yeah, you have not enough hands to do this actually. Yeah, and the other part is you can also simulate bigger movements of the baby. Yeah, so you can put into the water tank a baby that is actually moving and adding low frequency noise to the signal, and you can use then light emitting diodes to simulate the maternal heartbeat. So you can really build a very rich machinery that allows you to do independent research on the quality of the different devices. And our vision somehow is that as home monitoring in particular will take off, but it's the same applies to monitoring devices in the clinic, that there will be some pregnancies that need device 1, and others, they need device 2 or a whole series of devices, as Olaf has done in his high-risk groups. I mean, it was not just the CTG, they had blood tests and so on. Yeah? And so that's what we'd like to do. And we are very open to have collaborators to join this effort. Yeah? Okay, and I also want to highlight the fact that, I mean, the students that have not produced this video and so on, but they had no idea about this field a couple of months ago when they started. So I'm personally really impressed about what they've been doing, yeah. So it's very positive. Yeah, and they should all feel very encouraged about getting this feedback from such a distinguished audience. Yeah.